Okay, I don't know if you remember me telling you this. Hopefully you do. Delta E is equal to Q plus W. The last couple of videos, we dealt with the heat aspect of it. So now we're going to deal with work. And remember that work, and specifically this is, okay, I know you heard that. This is pressure volume. I'm going to have to close the window. They are very noisy. Specifically, this is what we call pressure volume work. Okay, and that'll make sense in a second. So let's just say we have a cylinder. And this is going to be one of my fantastic drawings. And that cylinder has a piston that can move up and down. And this is open to the atmosphere. Okay? And inside of here is a gas, and we're going to call this our system. Well, I'm not going to say specifically what it is, but that's our system. It could be a gas, it could be a reaction, it could be whatever. And this is open, so we have what we call external pressure, or PEXT. That's external pressure. And this is just sitting on a bench top in the lab. It's going to be atmospheric pressure, which we've not talked about. But anyway, the problem usually defines what they're talking about. So we're going to say here that the system expands. Okay, and let's not worry about why it expands. Let's just say that it does expand. And so let me redraw my piston. And this could be any kind of container that can expand or contract against an external pressure. So our system is expanded. It got bigger. Okay. What did it have to do to get bigger? Well, it had to push against P external. So what we say here is that the system did work on its surroundings. Okay, the system did work on its surroundings. So what does that mean? That means it lost energy. Delta E is less than 0, because delta E is always for the system unless we say otherwise, which we're not going to. Delta E is for the system. So that means this is a negative value, meaning it lost energy. Okay? So we can say that's a loss of energy. And again, loss of energy for the system, because it had to push against that external pressure. All right, let's look at the opposite case. Let's say that the system contracts. And just so we're all clear, when I say the system expands or contracts, it could be because, say, the system expands because gas is produced in a reaction. The system could contract, for instance, if gas is consumed in a reaction. So if you have fewer moles of gas, and now you have more moles of gas, the system will expand. If you start with a lot of gas and you end up with few moles of gas, the system will contract. Okay, so let's draw our cylinder again, maybe. Okay, and there's our movable piston, and here's our system. The system contracted, but we still have P external pushing down on that. So what happened this time? Well, it's exactly the opposite. Okay, the surroundings did work the system. So what does that mean? Well, that means that delta E is greater than 0, okay? Because the system gained energy this time, so delta E is positive. The system gains energy. Okay? So if you remember back to the definition of work, work is equal to force acting over a distance. Now, I'm not going to go through the whole derivation because I find it tends to be, well, boring. If you want to look at it, go ahead and look at it in the book. I'm just going to give you the final equation because we don't really have a force here that's easy to pick out, and we don't have a distance that's easy to pick out. We do have a volume change and we have a pressure. Now, we can relate those to force and distance through some algebra, and it really is just algebra. But this is what we come up with. Work is equal to negative P external times delta V. W is work. Work is measured in joules. P ext is P external. I'm sorry, let's write it this way. External pressure, because the system will have to expand or contract against that external pressure, and that is measured in atmospheres, ATM. Okay, we'll talk about that a little bit later when I talk about gas laws. And this delta V, this is change in volume, measured in liters. And change in volume is always final, whoa, not T, V final minus V initial. Those deltas are always final minus initial. Okay, in the next video, we'll do an example.